Hi there, this is Alicia looking at Notebook Cast from the student perspective. So in my classroom, we always do an introductory lab at the beginning of every single unit. So it's a discovery lab. And how it works is students come in that day, I do some form of demonstration, and then from that demonstration, they decide what they've observed, they tell me what they can measure from the lab, and then ultimately they form essential questions to test themselves. So the lab that I'm currently looking at here is the centripetal motion lab, and this one typically has two essential questions. How is acceleration affected by the radius, and how is acceleration affected by velocity? So I pretended for this lab that if I had group mates, we would split up the work where one of the group or two of the group mates looked at acceleration versus velocity, and then I looked at acceleration versus radius, and then at home we would collaborate using the notebook cast so they can see what I got, I can see what they got, and what their conclusions were. So if I go ahead and pop over to here, let's just go ahead back, and if I were to look at from the student perspective right from the beginning, logging into Notebook Cast, I would see my dashboard. So I've already created my whiteboard, so I don't need to do this, but I could just go right into my boards. And we can see over here that I've done this a couple times, but let's go ahead and click on that final try. And in that final try, I'm going to make sure that I can collaborate with my group mates. So I would go over to the invite and I would make sure that they would have this code. So once they had this code, all of us could look at this whiteboard to know what I'm doing, what I'm thinking, and then we could also chat down here in real time if we needed to. So we can see the top of my whiteboard has acceleration versus radius. For the sake of the whiteboard, I decided to put in the steps that I used. So I graphed the data, I linearized the data, and then I formed the mathematical model, which is what we can see here. So the data is here. Here's the graph. I found that it was that inverse relationship, linearized data, trend, and then the ultimate goal is always to form that mathematical model. So that would be the focus of the discussion between myself and my group mates. And then during the actual large whiteboarding session that we would have in class. And that would be a large discussion among the entire class where we would present all of our data and look at trends, similarities, differences between everything that we saw. So what I would do in order to collaborate with my group mates is take a screenshot of this, and then I would upload it into this whiteboard because this is ultimately what I'm going to show to the whole class. So in order to do that, we go ahead and click on the picture icon and we hit upload images, and you can see that I've already tried to upload an image, but unfortunately, it's not quite working. Even if you click here, nothing happens on the whiteboard. And unfortunately, from everything that I've looked at, it is just supposed to upload right away, and it's supposed to upload right to this whiteboard. So even if you go into kind of some helps, which is what I tried to do here, but this is a last attempt. Unfortunately, there aren't quite answers to that question right now as to why these images are not uploading right to the whiteboard. So even if I try to upload a new image and I choose a file, I have another screenshot. So let's go ahead and open that. And then I already see it is down here, so I can go ahead and X this out. But we can see once again that unfortunately it's not uploading. So at this point as a student, I would say, okay, well, that's not working. So even within this document, I'm going to have to go ahead and share that with my group mates, but I still want to be able to use this whiteboarding function. So what I can do is, knowing that it's both an inverse relationship and then a linearized one, once I do 1 over the radius, I can just go ahead and draw that so they at least know what I'm doing within this whiteboard. So let's go ahead and make that a medium thickness. And I'm going to go ahead and write 1. And I saw that here's my graph. My radius is on that x-axis. Let's not forget my units of meters. Then we have our acceleration on the y with meters per second squared. Let's make sure I get that in there. And we know that it's that inverse trend. And then in order to linearize, I know that I have to do 1 over x. And then my second linear graph shows 1 over r with the units of 1 over meters. Oops, that wasn't very pretty. And then we still have acceleration that didn't change over here. And now we have our linear trend. I could have made that a little bit nicer if I wanted to put a shape in. I could have put that line and then made that nice and linear like it's supposed to look. So unfortunately, my image didn't upload, but that's okay because we can still show what it's going to look like on the big whiteboard. And I could still collaborate with my group mates to tell them what I saw, what I needed to do in order to linearize, and then how my units changed because of that. And then at the bottom here, we see that I have my conclusion. So I did conclude that it was an inverse relationship. My slope is my velocity squared. And my F is equal to ma equation still applies in this new equation as the acceleration. But this conclusion doesn't make sense if I don't include my mathematical model. So what I can do is go ahead and add in a text. Nope, that's not what I want. There we go. Now let's go ahead and add in a text. And I'm going to add in that mathematical model because I have to have the goal there for everything to make sense. So A is equal to 0.349 meters squared over seconds squared minus 0.1341 over meter because I did have to change those units. Okay. And there we go. Now, the one thing you do have to note is once you get it in place and you hit that checkbox, that is now locked. So that is locked in place so my group mates can see that that is my model. And these are the conclusions that come from that model. So yes, we kind of hit a bump along the way with trying to upload these images, but that's okay because we can still draw it out and my group mates can still know what's going on and we can still collaborate. Thank you for watching.